Hello and welcome back, and as you can see up here I have my GPSDO, which provides me with a very accurate and stable 10 MHz reference crystal oscillator in an oven, which is nudged by the GPS signal to keep it on exactly 10 MHz. And never quite worked out what this display means, because how does it know that it's got all those lines on the end of it at the moment, and it will go up to 10 at times and then it'll go down a bit, but how does it get that information? Well, that's beside the point. That's not what I want to talk about. When I first got this, it only had 1 10 MHz output. So I made up a little distribution board, and using surface mount components, and I fitted that inside. I put another socket on the front, and on the back, if I can turn it round, which is not easy, you see what we've got on the back is, because I'm trying to run so many things off it, I had to basically use a T-piece, and they go to my 2 frequency counters, and then I've got another T-piece here which will probably go to my 2 signal generators. Now I've still not got enough outputs, because it's not really the ideal thing to do, to just connect 2 output cables together like that. I mean, it's always been fine, it's never had a problem, and I believe there's an unused 10 MHz output there, which is what you normally get with it. I added these extra sockets on the top. So what I thought it would be nice to do would be to build another little box which will give me even more outputs. In other words, another distribution amplifier, and it's gone to 10 MHz exactly now. Another little box that will sit on top of it and derive its power from this unit, because it will take next to no current at all. So the power supply that powers this will quite happily power another distribution box. So that will give me not only get over those problems with those T-pieces, which I don't really like, it would also give me the ability to feed a signal down to the function generator, and should I need to, the spectrum analyzer down there. Yeah, the spectrum analyzer's got its own 10 MHz reference input. It's not something I normally need, but because but it could be useful if you're measuring in a very narrow bandwidth and span on the spectrum analyzer. It's nice to have your signal generator locked to the spectrum analyzer. So okay, I'll go down to the bench and show you what I've been up to. So this is the circuit I'm using, and I've used this circuit before in the GPSDO. It's uses an LM6171B, which is a very high speed op amp. It's got unity gain at 100 MHz, so it's more than good enough for 10 MHz. And it wasn't too expensive either. I think it cost about £5, which is not bad for a high speed op amp. And what we've got basically is 10 MHz coming in, AC coupled, because I'm running this op amp on a single ended supply, and op amps normally have a plus and minus supply. So we have to create a virtual ground, if that's the right word, or in other words we have to pull up this pin to half supply. The non-inverting input pin has to be pulled up to 6 volts, because otherwise they would earth this pin. Well, you can't just connect it down to earth, obviously. That's yeah, you can't just do that. But anyway, so that's why I've got a DC blocking capacitor, and I'll get 6 volts at this point, plus or minus a few millivolts. And then you've got feedback network. I'm using 3.3Ks, by the way. They're not critical really, as long as you don't get too low resistance, and then you'll load down your 10 MHz input signal. But 3.3K is not going to do any harm to anybody. So then what we do is we stick it into the non-inverting input, and the op amp is configured as a amplifier, not a non-inverting amplifier. So it's got feedback resistors of 470 ohm from the output to the inverting input, and a 1.8K which does go down to earth. So you can take that down to earth, no problem at all, because you just have to adjust your value there to get the gain you want. And if it was a plus or minus supply, you'd have a different value there, of course. So what else have we got here? We've got a bit of decoupling, a 0.1 and a 10 microfarad. Fairly close to the chip is ideal. And then, because you're going to have a DC voltage here, which will be half supply, I believe, 6 volts, you've got to AC couple that, and then that goes into basically matching resistors to feed coax. And I've decided I wanted 4 outputs. I could have had more, could have had less. The op amp will drive quite a high current, something up about 100 milliamps I think, but in this application it won't ever see a load like that. But so you just need a bit of impedance matching to drive a piece of coax. And not that the inputs on the back of my instruments have got 50 ohm inputs anyway on the 10 megahertz, but whatever, it's just good practice. And 4 outputs at 10 megahertz, and that's basically all there is to it. And I built the circuit up using surface mount components about a week or 2 ago, but I think I'm going to rebuild it now. And you can see how small all the components are, because I like working with surface mount components. My eyesight's pretty good still. I don't need glasses for close-out work, strangely, at the age of 60. And occasionally I use a eyeglass that belonged to my father, who was a watchmaker, when I want to read the values on the components, surface mount components. But that's your op amp anyway. That's the pin 1 marker, and inverting, non-inverting inputs, and number 4 is earthed, and 5 is not connected, 6 is the output, 7 is plus volts, and 8 is not connected with this particular device. So it's a perfect application really for making a very small board using surface mount. That's your 470 feedback resistor, and that's a 1.8k. This is part of the feedback circuit down to earth. There's the two 3.3k resistors, which biases the input to 6 volts, input coupling capacitor connection for the coax, 10 megahertz coming in. Did I talk about decoupling? Well, there they are, a 0.1 and a 10 micro. Amazingly how small these get these days, 10 microfarads in a small package like that. I think that's rated at 35 volts as well. Now anyway, on the output, pin 6, we've got a coupling DC blocking capacitor and just a track to connect up to the 47 ohm output resistors and little terminals to connect to coax. Just because I could, I wrote the date on it when I made it, which is the reverse in America, I realise. And it was the 7th of June 22. In America, of course, it would be 6/22, but we won't talk about all that. But having done this, I thought, well, what box am I going to put it in? I haven't got a box to put it in, and I just thought I'd make it as small as possible at the time. But trawling around on eBay for boxes is something of a nightmare, because there's millions of them. Most of them are made in China, the cheaper ones, and I didn't want to spend a hell of a lot of money on it, and I wanted to make it as small as possible. So I eventually came across this one, which has just arrived from China, and I think they promised me somewhere in July this would come. I think it came within 3 or 4 days, which I think is incredibly good service from China. And it's a nice little well-made box. It's, if I can get the light in the right place, it's what I like with these boxes is you've got a slot where you can mount a circuit board going down there on each side. So what I'm going to do is I'm going to use hot air, because I don't want to waste components. Can't afford to waste surface mount resistors. Well, I can't afford to waste that chip. I'm going to take hot air and get all the components off this board, and then I'll make up another board which will fit in here, and it can go flush, I think, right up to the case at each end. The next challenge is getting the BNCs and power connector on it. I think I've lost some of my nuts, sadly, for my BNCs. So I retrieved my nuts which have fallen on the floor. It's always a good idea to keep hold of your nuts. Anyway, BNCs. I've got loads of scrap BNCs, because I always recycle stuff. All come with nice little washers and nuts. And the challenge is to fit as many as possible on the back, plus a power socket, which is also recycled. And I can, if necessary, shave a bit of plastic off this, because it doesn't need to be as wide. And I want to mount that on the circuit board, obviously. And that'll go there roughly. And then I've got room for 3 BNCs on the back. I would have preferred more outputs on the back, but one of them's going to have to be an input from the GPSDO, obviously. Then I'll have 2 outputs on the back only, and I'll have to make do with 2 on the front, which I don't really like, because I I prefer all my cables to go from the back of our unit, but there isn't any easy way around that unless I've got a bigger box, which I didn't want to do. So I don't really think there's much more point in talking about how this is going to work, because obviously on the front it's going to be easy. I'll only have 2 BOTs, and the nuts fall off, of course. 2 BNCs on the front, but as I've got loads of space left, so I might as well put an LED in it. I suppose I could have had another output, but I don't see the point. I don't think I really need another output. On the front, I think 4's enough. So really I don't think there's much more point thinking about the box at the moment. What I've got to do is get all the components off this board, keep them all nice and safe, because you know what it's like with surface mount components. We've only got to breathe on them and they disappear into infinity, or they become lost in space. But I should use all the original components. I've got more of these resistors and capacitors, but why not reuse them if they're in good condition? So I've got to make a much bigger board that fits in the box, and that won't be happening in the near future because I'm quite busy helping my friend get ready for the Glastonbury Festival, which is coming up soon. And he's under a lot of pressure now because he's only got 4 days left before he leaves. So I'll get back to you when I've made some more progress. So that's the old board with everything removed. As you can see, you've really got very little spacing between the IC pins. You've got that's the earth, non-inverting, inverting, and not only that, I had to put a track through the middle underneath the IC to connect up to the output, to connect to the feedback resistor. But I'm guessing these tracks are about 1 millimeter, roughly. Could be a lot worse. I've worked on stuff with 0.5 millimeter pin spacing, but anyway, that all went very successfully. I hope the op-amp's still alive. They normally can take a fair bit of heat, and that's where they all live at the moment, in their respective positions on the circuit diagram. Now the next thing to do is to draw out another board, which I'm not going to do today, and I'll get around to that soon. Okay, so this is where I've got to. I've cut the board to the right size, and it is an absolutely perfect fit in the box, and that goes on like that. Perfect. And what else did I do? I've got to drill some holes for this socket, which I can tell you is not easy. Getting your positioning correct is very hard. I had to use a paper template, push down on this onto the where does it go? It goes like that. Push it down on the bench and make those marks, and then mark them on the copper board. And the hard bit is getting those elongated holes drilled out, and they're not perfect, but it is quite a challenge to get those in a right position, and that fits in there nicely, and it's flush with the front, which I'll have to drill a hole in. And the other problem is that because the BNCs have got nuts on them, and I want to keep them central, otherwise not up, they've got to be in the middle. So their nuts will hit the circuit board, and you don't want that happening. So I've got to cut out a piece of copper on each side, and I don't like the look of that. It looks like it's got about 0.5 millimetre difference between that end and that end. And anyway, in order to do that, I actually use one of my favourite tools. My dad always called this a piercing saw. Some people might call it a fret saw. It was his, and he used to be a watchmaker, so he'd have to cut things occasionally, fine pieces of metal. But it is very easy to cut this fiberglass, but it does blunt the blade, which is interesting. And then I've got to get on and do that. So that bit's done. Cut my slots out, and gives me I'm now able to do up the nuts without them fouling on the board. And the next bit is probably the most tedious part, is laying out the printed circuit board with one of these pens, which is etch resistant. And I'm not one of these people who lives in the 21st century. I can't be bothered with software and getting boards made in China. I can knock a board up in probably 2 hours from drawing it out to etching it by hand. Okay, it doesn't look very pretty, but it still works just as well. So I'll get on and do that. Okay, so that's the board laid out with etch resist. It's a tedious process because you've got to fill in as much copper as you can, otherwise you're etching it all away and exhausting your ferric chloride, I guess. And it's not going to look great, but it will work. That's the main thing. I'm just waiting for the ferric chloride to warm up and I can etch it. So here's the finished product after etching, and it's far from pretty. There's a lot of pitting where the etch resist didn't cover it up fully, but the good news is there's absolutely no shorts, even on the tracks which are really close together. So I'll just get all the components soldered on there. I'm not going to bother coating it all with solder, which I have done on the other board, because it uses too much solder and solder wick as well, which is how I normally do it. So I'm going to solder all the components on, because I'm aware this video is going on far too long as usual, and everybody's lost interest by now. So here's the assembled board, and I've wired it up ready for testing. We can zoom right into that tiny little chip there, which is fine, and I've got it wired up and connected to the power supply, and it's drawing 5 milliamps, which is hardly anything. In fact, the LED is probably going to draw more current than that. If I look at the input signal and go over to the scope, we have 1.64 volts RMS. And if I go to one of the outputs, I'm getting 2 volts exactly RMS output. So a bit of gain in the circuit, and of course if there's any significant load, that voltage will drop a bit because of the 47 ohm resistor. There's enough waffling on, really it's down to metalworking, and that's going to be the fairly hard, just getting all the holes in the right places. So here it is, finally finished. Always glad when a project's over, because I get bored when it goes on for days and days. 2 sockets on the front. I've decided to have the input on the front, 1 output, and 3 outputs on the back power socket, which runs off the power supply that feeds the GPSDO. So just prove it works, which of course it will do. Signal goes in there from the output on this one, and cable from here to the scope, and there we are, a nice 10 megahertz output. Change the socket to one of the back sockets, and they all work. Of course they do. It wouldn't be much good if it didn't, would it? So that's it. That's fully finished, and fairly pleased with it. Box didn't need to be as small as it was, but I was just saving money. Sad fact is though, one day all this stuff's going to end up in a big hole in the ground, because nobody's going to know what it is or what it does. Anyway, thanks for watching. If you made it all the way through, thanks especially, and bye for now.